Hi, welcome to the chapter 2, section 3. We were looking at conversions of numbers. We also looked at addition and subtraction of significant figures. We are going to review a little bit on addition and subtraction of significant figures using the video here. We take a short review, then we will proceed with the new information. So what you're supposed to do is to add so our final answer here should not be more than 0.5. So our answer, we'll expect it to be having this as the significant figures. It should have at least 2 significant figures. That is our final answer. So we will round off this because it is less than 5. So what will we do? We will make this 54.5. The next example, when you are dealing with subtractions, it will also be the same thing. We are having here 17, and in 17, for significant figures, it has to be with the number 17, which has 1 unit. So our final answer should have the 1 unit because we are having only ones. So we will also round off here, and when we round off, we will get 3 as our answer. The most challenging, as we said here, is when you are adding this one. You know that all these are not significant, so all these are non-significant in terms of significance, and so when we add, we'll get 54,000.0, but our answer should have the list of the significant figures. Here we have 1, 2, 3, 4 significant figures. Here it has only 1, so we'll expect our answer to have 1 significant figure. So here our answer will be, in fact, but 50,000. Our answer will be 50,000. So that is our final answer here would be having 1 significant figure, and which will be 50,000. 50,000 has only 1 significant figure, which is 5. So this will be our answer. This is in terms of addition and subtraction. When we come to multiplying, let's see what happens. In multiplication, we will be multiplying here. Let's see what happens during multiplication. So during multiplication, what you do, you also use significant figures. So if we are multiplying these two, then our answer, our calculator will give us an answer 375 as if we put in a calc. But what happens here is that we have to round off our answer to significant figures. Here we have 2 significant figures for each numbers. So, and also this has two significant figures. So what we will do, we have to round off to two significant figures. So we will round this 7. If we round this 7 into we will round it off, so this will become 5. So this is, since this is 5, we will make it an 8. So we'll have 38. So 38, so the 0 is insignificant in this case, so 38 will be 380 because we don't want to have a different number from what we have here. The next one, when we divide this and this is the number that we will get from our calc. So how many significant figures? Here we look at the least one. This one has 1, 2, 3, 4 significant figures. This one has 1, 2 significant figures. So we are going to round our answer to have 2 significant number, which is the smaller number in this case. So if we are rounding off this, then our answer will be 3.3. Then we have the last example here. Here we are having the answer here as this, but we are supposed to round off to significant figures. Here we have 1. This has only 1 significant figures because all these are insignificant. So trailing zeros are normally insignificant. And the last one is having 4 significant figures. So our answer should be having 1 significant figures as the smaller number, which is this one. So it has to have 1 significant figure. So if we round off, so we have to round off to, so this is 5, so we'll use it to round, so it will be 3. So it becomes 3, and the other numbers will be 0, 0, because this is our final answer. So that is how we deal with both multiplication and division, and also we do the same when we are dealing with, so when we are multiplying or dividing, that is what we are supposed to do. So let's go to something else here. And now we will be looking at what we call scientific notations. So after the review, we will be looking at scientific notations is used to express very large or very small numbers. Is used to, so in scientific notation, numbers are written in the form m. Numbers normally are written in the form numbers are written in the form m times 10 power n. So they are written in the form m times 10 power n, where factor m is a number greater than or equal to 1. Factor m is a number greater than or equal to 1 or equal to 1 but less than 10. But less than 10. But less than 10. And n is and less than 10, and n is a whole number. and n is a whole number, and n is a whole number. So n must be a whole number. So for example, to put the quantity 65,000 kilometers in scientific notation, so if you are having 65,000 and you want to put it into scientific notation, and should show the first digits as significant, you would write it as 6.5 because this is less than 10. Then you would multiply by 10 power 4. So maybe you would ask, how did we get the power 4? We moved to the right, to the left 4 times until we put here the point. So 1, 2, 3, 4. So our power here is 4. So writing the m factor as 6.5 shows that there is exactly 2 significant figures. As you can see here, there are exactly 2 significant figures. So we are having exactly 2 significant figures. So if instead you intended to the first 3 digits in the 65,000 to be the to be the significant figures, then you would not write it as this, but rather you would write it as 6.50. You would write it as 6.50, and if you write it as 6.50, then you will not have moved 4 steps to your left, but rather you would have moved, let's see how many times you will have moved. Here 1, 2, 3, 4. That is if the decimal is here. But in this case, since we have retained a 0, then we will have to multiply it by 10 raised to power 4 also. So it will also be raised to power 4 just like in the first instance. But the only difference is that it will have a 0 here. A 0 here. So when numbers are written in scientific notation, only the significant figures are shown. Suppose you are expressing a very small quantity, such as the length of a flu virus. In ordinary notation, this length would be like something like 0.00012. This is millimeters. So that length can be expressed in scientific notation as, so in scientific notation, as we know, the number should be either equal to 1 and less than 10. So here we will have to move to a point where we will have this. So we will move from here, we will move the decimal point up to here. And since we are moving to the right, our power here will not be positive, but rather will be negative. Our power here will be negative. So let's see what happens here. We will see what happens here. So after having this, we are going to have 1.2 as the answer multiplied by 10 power negative 4, and these are millimeters. So this is what we would have. Since we are moving to the left, since we are moving, to the right, what happens is that our power will be negative. Our power or notation will be negative. So if we move so rule 1, determine m by moving the decimal point in the original number to the left or right, so that only 1 and 0 digit remains to the left of the decimal. So to the left of the decimal, we should have only 1 and 0 number, like we have here, And rule number 2, determine n by counting the number of places that you moved the decimal point. If you move to the left, n is positive. So if you move to the left, n is positive. If you move to the right, n will be negative. If you move to the right, n will be negative. So multiplication operations using scientific notations will include stuff like, let's take an example here. First, we will start with addition. So we'll start with addition. So addition and subtraction. So these operations can be performed only if the values have the same exponent. Addition and subtraction. So for addition and subtraction, these operations can be performed if only the values have the same exponent. So when dealing with addition and subtraction, the exponent n factor must be the same. The exponent n factor must be the same. If they do not, then we have to adjust them. To adjust so that the exponents are equal. So once the exponents are equal, the m factor can be added or subtracted. So the exponent of the answer can remain the same, or it may then require adjustment if the m factor of the answer has more than 1 digit to the left of the decimal. So let's consider an example so that it's easier for you to pick what we mean here. So if we have a number like this, 4.2 10 power 4 and 4.2 10 power 3, then we have to reorganize so that the exponents here will be the same. So that the exponent here will be the same. The power here, or the exponent, may either, so we can make both exponent either 3 or 4. We can make both exponents either 3 or 4. So here we have 4.2 multiplied by 10 power 4. These are kilograms. So we are trying to add. Then we are adding, we add this by 0.79. So you can see that we have moved a step here, and as we move a step here, this one is added, so we end up with times 10 to the power 4 kilograms. Now we can add, or we can find the total to this which will give us 4.99 times 10 power 4 kilogram, which could be rounded off, so which can be rounded off, so we'll round this off. So round off to 5.0 multiplied by 10 power 4 kilogram, or if we take this to be 7.9 multiplied by 10 power 3 kilogram. So here we decide that we are not changing, but rather the power will remain 3. Then we will have to change this by moving this to the right. So this one now will be the one which will change, and we will have 42 multiplied by 10 power 3 kilogram, and if we add, we will again get 49.9 multiplied by 10 power 3 kilogram. So we have 40, we can convert this to 499. We multiply it by 10 power 4, so we will have to move it, because we know that our answer should have only one digit to the left of the decimal point. So we had to move this digit, and as we move it, the power will increase. So this is in kilograms, rounded to 5.0 multiplied by 10 power 4 kilogram. So note that the units remain in kilogram throughout. So we will stop here for this video. In the next video, we will be looking at how we can do that with multiplication.